My name is Kayla Viveros, and I am a program manager with Polaris MEP. And thank you for joining us today. We have a great webinar for you with, to scan your facility layout with functional 3D. Polaris MEP helps our manufacturers with the top line, bottom line, and pipeline. We have many services to support our manufacturers like lean, quality, and facility layout, which are all delivered by our team of experienced manufacturing experts. We also have to lots of times support our manufacturers in ways that we don't have experts for. So my job as a program manager is to help source partners in the community, vet those partners for you, and make those connections. And then I sit on the side as your trusted advisor for you as a manufacturer and help project manage that project all the way through. So we are here for you with any of your manufacturing needs. And I'm excited today to introduce Chris. Take it away,
everyone.
Chris.
Thanks. Chris Wilczewski. I'm with, I founded and the head of Functional 3D, a 3D scanning organization. And we focus on scanning for any applications really, but today we're going to be focusing on facility layout. So our presentation today and our discussion is going to start with some additional introduction of who I am, where I got started. Then we'll get into what is 3D scanning for anyone that hasn't experienced it or dealt with it or worked with it. What is 3D scanning and what does it do? Then we'll get into, I'm going to go over some of the challenges with typical site documentation. Some of you probably have already experienced this, but for anyone that this is new to or maybe sits above these types of discussions, understanding what the traditional workflow is currently is good to have an understanding and a starting point, and then we'll get into what the 3D scanning workflow looks like when you implement that either alongside or on top of instead of rather than a traditional method. And then we'll have one of my partners that I've worked with and I've done some work for in the facility world, Windmuller and Holscher. My apologies. Will be joining. Edwin will be joining to give us some of his insights and what he's seen and the value it's brought to their workflow when utilizing 3D scanning over a more traditional hands-on measurement technique. And we'll finish up today with questions and answers. So if you have anything, please put it right in the chat. And either we'll, if it's a quick one, we might be able to get to it right on that slide. But if not, we'll get to it at the end of today's discussion. So who am I? My name is Chris Wilczewski, and I have been in the tech space now for about 15 years. And the last 6 have been in the world of 3D scanning. So I spent 4 years working for and got introduced to 3D scanning by working for the company Faro Technologies. They're based out of Florida, the Orlando area specifically, and that's who makes this device right here. They are they have a range of both hardware and software products to capture the world and then do something with that data. So you can see here, we've got some examples. And then the other piece of my world is my son, who is now 4. He'll be going to kindergarten this fall. And that's and then Buster, who is my very old man, a very old dog. He'll be 17 later this year. So 3D scanning introductions, a little about me. And now we want to kind of talk about what is 3D scanning for anyone that hasn't experienced it. And for anyone that's interested in maybe even testing the waters or playing with it. So first and foremost, this can all be done with a camera or a drone. The camera on a drone can be helpful for large site or large scale captures. And some of this can be combined with multiple technologies. So I use a combination oftentimes of laser scanning and camera or drone photogrammetry to put the information together. And the final tool that I use at Functional TV at 3D is our, right here behind me, the stationary structured light scanner. That's able to capture very high resolution, a lot of information, but in a much smaller package. So for large scale facilities, we're going to be talking primarily about our laser scanner, and then actually a little bit of a 360 photos for documenting spaces as well. So what are the industries that are supported through this type of data and information? So scanning is used in all kinds of areas. So if you see anything else in this space, please don't hesitate to either reach out to myself or forward my information on. Kayla can make that connection as well. So we have historical preservation. One of my personal affinities that I enjoy working with and learning more about is that historical preservation, being able to create a three-dimensional copy, both in a physical, a digital copy of that physical size and information, but also very accurate color information. Industrial design, anytime you have something in the real world that needs to go into the digital and you want to design around it, 3D scanning can support that. AEC, architecture, construction. This is going to be the space that we're going to be really talking about today. Very similar workflows to facilities and the same types of information that are important. And so being able to capture what's there and how to manipulate that information and use it in a workflow like facilities is extremely important. But knowing where your mechanicals are, understanding where all your support beams, understanding things like wall thickness, and overall placement of a space is extremely critical to many different industries. Manufacturing, I can also supply information of a part is manufactured. You get it, it comes out of the manufacturing space, and now you want to check it to see how good it is, how close, what's the tolerance. And in 3D, that can be very difficult. 2D profiles, pretty easy to take some quick measurements with some calipers, but when you start dealing with complex curves, this can be very difficult to understand and take measurements of. And finally, film and video games. Anytime you want just a visual representation, a way to engage people with that information and give that nice, really clean visual representation of the real world, 3D scanning, photogrammetry, those types of workflows can provide that. So what can all of this information do is provide, like I said, a digital digital twin or representation of the real world in full 3D, in color, everything in the computer. So it can all be brought in, and you can see right here, this is a submarine. This is the USS Albacore that is on land up in Portsmouth, New Hampshire. So this was a project I'm working on right now, specifically for a documentary, but I just wanted to show the level of quality, detail, and information that can be captured from these types of devices and the workflows that I use. So what does traditional facility management look like? Well, you're going into your warehouse, you're going to your manufacturing space, and you're taking a ton of measurements. You're going to be doing the best you can to document measurements. You're typically going to see a two-man team working this, holding one end of the tape measure and pulling it to the other, or you're going to be getting up on lifts or ladders in order to be able to pull the dimensions properly. And all these dimensions are only as good as the people pulling them and the knowledge that they have. You're going to be taking a ton of different photos to see where everything is. So when it gets brought back, there's some context to the measurements that are taken. Lots and lots of notes are being taken, and hopefully they're decipherable. Hopefully the person at the other end, if they're not the same person, can gather that. So it's very time consuming. In particular, there's a lot of different points of failure. So reading a laser measure or measuring tape and then writing that down, there's that point of failure right there. and then we'll get into some other points of failure. But there's many different points of failure in this workflow, where double checking, triple checking different measurements as you're taking them to make sure they're right and accurate is critical to make sure your output is. And then the other piece of it is oftentimes assuming things like angles of walls are perfect 90s. When you assume that and things are off over 100, 200, 300 feet, if you're in a large facility and that angle isn't a perfect 90, those dimensions at the other end are not going to line up or are going to be off. So the real world isn't always going to match what the digital world that you're creating. So lots of measurements, both with measuring tapes and laser measuring, lots of photos, and lots of notes. And then that comes back into the office. You're sitting there, or all the notes are passed off, the photos are passed off to your modeler, and they're trying to decipher all of these notes, put them together, read them, and start to create a workable piece of information from that. And this is another point of failure. Was everything legible that was written down? I have heard countless times, I didn't know what that meant. And then was it written down correctly? If something was wrong in that process, then there could be quite a bit of wasted time trying to assume some things or figure it out, maybe from photos. Things don't make sense, things don't line up. And so that can be very, very challenging to try and decipher all of that field information when you're sitting behind a desk and maybe you weren't the one out in the field taking all that information. Now you're modeling everything. You're putting everything in the computer. Like I said, you're hoping everything lines up, and you're spending a lot of time modeling everything that was documented. So that way you understand where it is all in three-dimensional space. You want to put a new line in. You want to redesign your layout. You need to know where everything is when you're starting from that position. So you have to model just about everything in order to see it in 3D. You can't just drop it in. So this can be very time consuming and require that continuous modeling of everything that was documented and everything that's in the photos. So that way, you don't necessarily know if it's going to be critical or not. And this is one of my favorite. Let's just hope it's all right. And some of it can be figured out when the modeling process is taking place. These dimensions come in. Does the pipe diameter make sense? All these different pieces of information. But there's a lot of hope and a prayer situation that happens during this process. There's, they got photos, but there's no dimensions in photos. So these can be very, I hope it works. And then if something doesn't make sense, or you can tell it's wrong, hopefully you can tell it's wrong, you're going to be going back on site. And for some of my clients, this means multiple states away. This could mean multiple days of downtime for one or two people to go back out into the field, capture that information, and send that back to headquarters. So time is money. There's a lot of waste that can come from this process that can be avoided. And but let's face it, it's still less wasteful than going out into the field, not realizing you had a problem, and going out with the wrong equipment, things measured to the wrong distance, and now you have to scramble on site during an install. Your new piece of equipment doesn't fit, those types of things. So now let's talk about, what does the modern workflow look like? So first and foremost, I mentioned, just kind of touched on it, 360 photos can be very, very effective for facility layout, some visual reviews. I can take that information in, give a web platform. Basic rough measurements can be taken from 360 camera information, and it's processed and used as a photogrammetry method to be able to provide that workflow and that information. It also makes it easy for multiple facilities, someone who's managing multiple facilities, to jump from facility to facility to maybe see what piece of equipment is on site, maybe check a serial number, make annotations so someone on site can see exactly what you're talking about. You can share the screen, you can move through a facility. So there's multiple ways that this data can be very valuable to especially a multi-building organization. Next, we're going to be talking about, which is my primary offering, is laser scanning. So this is going to use a 3D laser scanner, and it will allow for very, very accurate measurements to be taken of a space. And we're going to go ahead and start that just to show kind of an animation of what this is, how this is working. So similar to the way a laser measuring tape works, this unit is going to fire that laser out from one side. It's going to bounce off of that 45-degree mirror, and that mirror is going to start spinning. And so it's kind of painting essentially and taking multiple measurements up to 1 million points per second. So up to 1 million measurements per second. And then the whole unit itself, as you can see right behind me, will then spin around on that tripod in order to capture everything in a full 360. So that data comes out of there, and we then have a point cloud. So here's what that point cloud can look like of a facility. You can see, and this is just one scan position, and I kept the point small, so you can kind of see a little separation between them. But even so, these are clusters of some points together. But we can easily see that we have mechanical information, pipes, we have our beams, we have racks. And so these are taken from multiple positions around a space. This is line of sight, so it can only capture what can be seen. There's nothing on a large scale like this, maybe some ground penetrating radar type of situations, but nothing can really see through any objects, no X-ray scanning just yet for in a facility. So we would take multiple scans from multiple positions, and then we put those all together. And that gives us a full picture. So you can see each one of these points is where a scan was taken. These are clusters of multiple scans kind of taken right on top of each other. This is going vertical. And very quickly, we can take this information and create this kind of 2D ortho of our scan data. So once we put that all together, combine it in the computer system, we can then actually export just this right now and get a fairly usable floor plan. It is just an image, but we can scale this image now in our CAD platform with our scale bar down at the bottom, and we could just draw right on top of these lines, and we could get our vertical beams there, our supports, we can get our walls, we can get some other horizontal beams, and get an understanding of a general layout. All right, we've maybe got, this is some objects that are in storage. And so we can get that general layout of our facility very quickly in a 2D manner. But the real power is what's it look like in 3D. And so each one of these, depending on what's necessary for the project, we're going to be taking more or less of these in order to be able to represent everything that's needed. So if we need every piece of piping, right, we can see a little bit faintly some of the pipe runs. But then in 3 dimensions, we can take that information and start to model from it. So again, I think as Aaron may have mentioned in the preview, not everything needs to be modeled. And same thing when you're taking all those field notes, maybe not everything needs to be modeled. And so that can be very time consuming, not only to take those measurements in the field, but also time consuming now back in the office when that person, whoever that is, has to model every single piece of what was documented in order to create that full picture. In the case of this, we can combine models and point clouds together. So you can get that visual aspect of understanding, okay, how far away am I maybe from this to there? And you can put the model of your new piece of equipment from the manufacturer or just in general, dimension shapes that you create. And you can put that in to see how that fits in the rest of your facility. How is it going to connect up based on where your mechanicals are running from? What's it going to cost? So this information can be shared very easily. And so I'm going to jump over to the web platform I use called WebShare. And you can see how we can actually move around this space in full 3D. Not only that, we can measure. We can take measurements right in here. So I can select measure distance, and I can measure from one point to another. And now I've got my measurement right there. I can get vertical if you're worried about maybe selecting. So anyone can pull tape from this data. Anyone can essentially go on site and be able to take a measurement. We can also do things so we understand what our horizontal, start to end, vertical usually. Oh, there's the vertical. So there's a vertical dimension right there between the two. So in case there's a little X and Y difference, which there was, we get a very slightly different measurement between the 2 points I clicked and what the exact vertical is. We can create annotations, so we can take notes in a 3-dimensional space that we can share. We can share them across, this is all can be locked down to a specific users. So not just anyone has access with a link. I can make it open, but for a lot of the annotations and other capabilities, it is required to have an account. But we can take annotations that, is this what you're talking about? Is this the piece of equipment? This is going to move. Information can be shared in a 3-dimensional manner that pictures just can't offer. And so we can see all this and be able to capture that information. One other as well, I really like to show is the orthophoto capability. So you can take top down or a front view and create an orthophoto from that information. And we can see it, this one, information. So we can see that now this can be brought into our CAD platform. It can be scaled and be then utilized to draw exactly what we need to draw right from this. So quick information and the ability to share what's around in 3-dimensional space, we've found to be extremely important and valuable, and provide an unprecedented ability to share this data very quickly. This can be done, the scan data can be combined after being on site a day or less typically. It can be combined typically that evening, maybe the next morning, and the following evening, this information could be up and starting to be used. So it's a very quick process to go between the two, from on-site to being able to work with data of that, where obviously modeling can take a lot longer in order to get that done. Oh, nope, that's not what I wanted to do. Next. And then finally, the modeling piece of it, this 3-dimensional information with the right tools can be utilized to actually create those models in full 3 dimensions by just clicking on them. So this tool right here is a plugin for AutoCAD and Revit, and can automatically detect these cylinders, and it is using MEP information, a catalog, to understand, these are carbon steel 600 pipes, whatever it's using right here. So 8-inch, and it's adding that information. So it's very quick to start to model in full 3D this information very accurately, without having to, and you can see it now against what's there in real life. So you're not just assuming, okay, this is at a perfect 90 from this to here. This is at another 90. So this can show you where things are in the real world, as opposed to, say, assuming that, okay, from here to here is 90 degrees. It was off this far from the wall when it came out. And then you can use that to snap everything together. So there's some amazing tools that can be utilized in getting you into workflows. I'm not sure what workflows everybody uses, but that is the majority of it. And Edwin, did you join us yet? He was going to join a little bit later. Did we get, hey, there he is. It shows him, actually perfect timing. It looks like he's connecting right now. Just a little introduction. Windmuller and Holscher is a previous client of mine. Edwin and I have worked together on a couple of projects now for the blown film lines, and he's had some experience utilizing the data we've provided and putting that all together. So it still looks like he is connecting. You're muted, Edwin. There we go.
Hey, Chris.
Hey, perfect timing.
Wonderful.
we just got to you. So yeah, if you want to, I just gave a little introduction about who you were, and WH, and if you want to kind of just go into what your experience has been working with the point clouds, any value or challenges you've found with them, and yeah, your experience, if you don't mind.
Sure. So I guess, Chris, I'll just assume you gave a pretty complete introduction of myself, but really briefly, I guess the highlights from my side are that it's involved with installing large machinery that comes from Germany. We have about 20 containers or so worth of 20, 40-foot equivalent containers that come from Germany for any given line. And we install these into factories. So oftentimes we are up against needing to shoehorn something into a very tight space. A lot of times with existing plumbing and building structural steel to maneuver around, not to mention other manufacturing equipment. So that represents about, I'd say, 20% of the projects that I work on have tight spaces like that. So we had several incidents over the past year prior to my joining, where either due to mismeasurement with a laser tool or due to out-of-date drawings, we would order a steel tower for our product to sit on, our manufacturing line to sit on, and only to find out in the weeks of assembly of that line that that tower was not sized properly to the building. We had interference. So of course, not only does that cost us, cost W&H in terms of having to rework the steel, but we have to redo our drawings. We have to spend extra technician time, and we have to pay our riggers more to make up for that additional time that they weren't otherwise anticipating. So lots of costs involved with that. And of course, it's just a headache to deal with as a manager. You don't want to have that. So we first considered buying a 3D scanner, but when we looked at the cost of it, we found that paying, I think it was somewhere in a range of $70,000 or so upwards for a high-end scanner. Not only was that a little shocking to us, but we knew from previous experience that there is quite a learning curve to using these devices. So it's not something that's impossible to use, but it's also not something you can just throw into anybody's lap and say, hey, I need you to quickly take a scan like you would take a picture with your iPhone or something. So my boss challenged me when I said, okay, well, let's buy one of these things. He said, well, no, what about getting scanning as a service? So we are located in Lincoln, Rhode Island, about 10 miles north of Providence. And this was probably August or so of last year. I was faced with a project where I knew this was going to be a possible challenge. And so I looked around both in Ohio where this project is taking place, excuse me, in Pennsylvania where this project is taking place, as well as locally. And I reached out to a couple of people, and one of them, of course, is Chris. And you know, we had a very good collaboration over the course of last year. I was very happy, Chris, when you were able to go over there to Malvern, Pennsylvania, basically at a drop of a hat. And I said, hey, we need this on Monday. And it was more or less, I think you were there on a Wednesday or so, or Thursday. Yeah, I mean, that's kind of the background of you know, how this came to be about, how I came to work with Chris.
To your defense, though, you did get your purchasing people to cut that PO pretty quick. So
yeah, that's I guess one of the advantages of working for a smaller company is you could just pick up the phone and get them to do stuff like that really quickly. But yeah, I'm glad that we were able to get you taken care of in that regard.
Yeah. Excellent. And I know we did the web share. Any comments or feedback on that?
Web share. Okay. Yes.
The web interface.
Yeah. 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 So I guess you were there for a day doing your scans, and you know, I think it's worthwhile to mention that you were there basically, you know, you were there with nobody from my company there. So you basically just showed up to my customer, and of course I let them know, but you know, you were able to navigate the plant, you know, without incident, from what I understand. You know, that it didn't cause any kind of downtime or anything like that. So about, I think 2 or 3 days later, you said, hey, here's the link to you know, this website where you can see the scan results. And originally, really all I wanted, or all I was expecting, is to be able to get a file with this point cloud, because our design team over in Germany is able to digest that and look for interferences. So I was actually pleasantly surprised this was something else that we'd be able to get. But Chris, after about 3 or so days, maybe I think it was even shorter than that, after your visit there, you had you know, you had downloaded all the data onto your computer. I think you cleaned up a couple of things, and then I guess Faro has a website that you have some kind of subscription for that allows you to share with your customers different scans. And you were able to set up a website for me that allowed me to look at my scan. I was able to, you know, it's basically like being in a video game, and you have a couple of dots, and you can click on the dot and you can move to the different space where a scan was taken. And at any one of those spots where you took a scan, you can easily pan around with your mouse to get a 360 you know, view of that particular space, just photographic view. And in addition, the website allows you to switch over to you know, look at it in a point cloud, which is not my preferred way of doing things because that slows things down. But just for getting an idea of what's going on in a particular location, it's great, because it means I don't have to travel as much. And it allows other people that, you know, actually this was beneficial just in bidding out the rigging work. So we have these people called riggers, and they assemble our steel, and I contract with them. And I think it's useful, especially when you're in a confined space, allow them not only to see the design of what W&H is making, but also understand, you know, how maneuverability is going to be impacted by that tight space. And there's really nothing better than making a site visit, but I would say a close second would be, you know, being able to see a 3D scan the way that that website allows you to see it. So that's that in a nutshell. Of course, I know you helped me a lot then also with getting certain people access, as well as also restricting that site so that, you know, we won't be losing our customers' data, or, you know, allowing other people to see our customers' data.
Yeah, thanks. Yeah, and then I remember too, you know, a lot of I think there was some conversations going back via that website, taking annotations and making notes from between Germany and Rhode Island. So that collaboration effort, not only between internally, but then that's great. That's the first time I'm hearing of you being able to use it with your customers as well. So I love
our contractors.
or your
But yes,
contractors,
yeah.
but yeah, sorry. So being able to use that for the bidding process, so you can probably reach more or get more bids. Because oftentimes, like you said, right, going on site can be challenging, especially in the days of COVID. Yeah, and then thank you for pointing that out. Yeah, as far as scanning on the facility side of things, as long as I can see it from one position, it's fine for people to be walking around, as long as they don't just stop and stand in front. I'm gonna be able to capture the information from either a different angle, or it's gonna be picked up from another scan position. So, or there might be just a little gap in data on a wall, but you have the pipe in front and the pipe in back, but someone was standing right there for a moment and we're missing a gap. As long as that gap isn't have anything that's critical, it's not really of importance. We still have the pipe. We know the pipe is going from one side to the other. Yeah, it's pretty, and I have different size tripods to be able to get up and over things, or I went up some of the at different levels, so you're getting top down types of scans as well. I put it on top of some pallets at different points just to get it up a higher, so it can avoid any of the issues where maybe someone's blocking information. So yeah, as far as downtime goes, it's minimal to none, with the exception, I think, when I worked for Faro, some people would ask if the equipment's moving, can you still measure it while it's still on? I'm like, no, it's moving. Like, it needs to stay still, like otherwise it can't take measurements. But all right, I think we've kind of covered a lot of ground and gotten through a lot of information. So Edwin, thank you so much for joining us and sharing your experience. I always like to have that voice from my customers, and so thank you very much. And as always, if there's anything I can help you out with, let me know.
All right. Yeah, my pleasure.
Take care, Edwin.
Take care.
And with that, we'll open up the floor for questions and answers. And I'll be happy to answer any questions anyone's had. I got the chat up over here. I'm not sure if we had any.
So I had a question that was directly messaged to me. It says, can the data be imported directly into AutoCAD?
Excellent. Great question. So yes-ish. and that's where a company like mine, Functional 3D, I really work to understand the workflows of my clients, what's necessary. As Edwin mentioned, the team in Germany was able to work with the point cloud data, whereas the team in the US didn't have that knowledge or working ability. And that's where I kind of step in. So I can then, in that case, I believe they were going into SolidWorks or Inventor. And so I built a step model for them to use from that data. And whereas in AutoCAD, we'd be going to DWG, DXF. And so I'd be using some of those tools to help create those model the areas of significant importance. And then, but yes, the point cloud can absolutely be brought into AutoCAD. But there's a caveat. It's not easy to work with. So you can bring it in there, you can see it, and that's where that visual overlay will come in handy, and maybe that's all you need. And that's where we want to talk about exactly what the workflow looks like, what you're expecting from this information, what you're trying to accomplish. So I can deliver maybe some of it modeled, maybe all of it modeled, maybe just the point cloud. I don't know until I have that conversation. So the answer is kind of a yes, kind of a no.
Perfect. Yeah. We have another question. It says, how would you compare the 3 days you spent on site with W&H to the required, or that time versus the traditional approach. So, you know, is there a time savings with what you work on?
Oh, you mean, I think, I don't know, I think Edwin stepped off. You'd have to ask him what the timeline would have been. From my understanding, it's roughly, as far as on-site time goes, it's about 5 to 1. So I was only there for about half or 3/4 of a day between setup, teardown, and of actually on site capturing information. So it moves very quickly. We did want color for that one, so that takes a little bit longer. But I was able to, each position was probably about 4 minutes, 4 to 6 minutes in most situations based on resolution and color for that. If we didn't need color, we could actually drop that down further to like a 1 to 3 minute scan. So I've kind of again, consult with my clients, understand what the needs are, the end result, and what you're trying to get out of it. So that way I can provide and utilize the settings, the proper settings. Also, yeah, as mentioned, time constraints, working around other people, maybe during downtime. But from what I saw in when I worked for Faro, they typically in their workflows, because I've never done a traditional go out and write a whole bunch of notes. So I'm not the person to have that experience. I know how to use the laser scanner. I'm not going to measure something like that. And so by hand anyway, I'll use the laser scanner to do it. And so it's a very fast process. And I believe it's about 1 week of maybe a 2-man team taking all those measurements. And again, it depends on how complex and what's required of the job. But for some of the MEP firms, the mechanical firms, different MEP, sorry, Kayla. So some of the architectural mechanical firms that are working in, piping and electrical, they saw if they were doing a heavy amount of modeling, it was about a 5 to 1 reduction. So about what would take a week of time for a 2-man team was about a day of scanning. So a lot of ground can be covered with scanning that you just would take a really excessive amount of time for a 1 to 2-man team to capture in the field.
Awesome. Another question would be, measurement wise, what's the tolerance between the measurements? How close can you get it to what I could get with a tape measure?
Absolutely. Great question. So the unit itself captures at ±1 millimeter. That's its stated level of accuracy for the LiDAR. My other unit over here has a stated level of accuracy. So we're talking about like parts and pieces. That one actually drops down to 0.08 millimeters. And that's certified. These are both certified devices. And I have the certificate of quality, I guess. I forget exactly what the terms are, but they are certified. This one through NIST and that one through the EU standard. And so, yeah, ±1 millimeter. So if you're in imperial, that's sub 16th of an inch level of accuracy at like 30 feet away.
Wow, that's awesome. All right, well, I will give a second here. If anyone else has a question, feel free to unmute now and feel free to ask.
I'll unmute. Chris, how do you help a manufacturer kind of put together a budget for this? I mean, you mentioned that Edwin was able to get that PO cut pretty quickly.
Mm-hmm.
But, for a lot of folks, you're working with a team, a cross-functional team, hopefully, when you're working with facility layout. How do you figure out the budgeting required for something like this?
So that's where that consulting, the consulting time, I sit down, I understand what the project is, what the goal is, what the experience and software packages and modeling packages that the client is using. So that way I can understand, and I then quote based on the amount of time. So I quote hourly rates. And then when travel's involved, I do have minimums on that, and then plus whatever the travel costs are. But that's how I then budget it for them, is to understand, right, is there, if it's just going straight from scan to point cloud data, that's pretty straightforward. If we're going to be getting into modeling, like you saw some of the basic structural support beams that I did the modeling for in that slide, that's on top of the combination. So we can tack on different capabilities and services that will save the client time based on their comfort of working with point clouds or whatever that may be.
Awesome. Thank you for that. All right. Well, I guess the next step here would be to,
Last slide.
yeah, if you want to switch slides, perfect. So this is my contact information. If anyone is interested in working with Chris, our next step would be for you to reach out to me personally. And what I will do is I will schedule a meeting with your team as well as Chris and I to sit down and talk about what your project is and what your company needs are, and we can evaluate that all together as a team. And then at that point, Chris will give us a proposal on what that looks like. So again, my information's here. If you have any questions, feel free to reach out. You will be receiving a survey after this, and we truly appreciate you responding to the survey. Generally, upon responding to the survey, we send out the slides of today as well. So the survey feedback also gives us feedback on how we can better assist you going forward. And I know that Chris has a couple webinars coming up with us in the future, so he would love the feedback on how he can help improve in the next few webinars.
Feel free to tell me how boring I am. Yeah, if I can plug those, we're going to be talking more on the smaller side of scanning and how that's used in both manufacturing and design. So manufacturing is going to be talking about specifically quality, understanding, like we talked about, I mentioned earlier, a fully 3D understanding of a part or product that's been manufactured. So you have your CAD, you designed it, it gets made either in-house or maybe you send it out, it comes back, and now you need to check it to see if it makes sense. I've heard plenty of horror stories, especially with plastics, where things don't come back the way that you sent them out. And then the other piece is the design process. Oftentimes we may need to, design around something that it'd be really difficult to take calipers to. You can imagine, how do you model that when your measurement device looks like this? So taking and getting three-dimensional information from something like this into the computer to design around is very, very difficult. And so that adds that 3D scanning adds that capability to bring it into the computer so you can work with it.
Awesome. And we just put that link into chat for those future events, so please join us for those. Chris, thank you so much for your time today, and everyone, thank you for joining us, and we hope to see you soon. Have a wonderful day.
Thank you, Kayla. Have a great day, everybody.
Have a good one.